Okay, so you've got a mountain of data. Now what? What do you want a machine to actually do with it? It sounds simple, right? But that one question actually splits the road ahead into two totally different but equally powerful paths in machine learning. And today, we're going to explore them both.
All right, let's put these two paths right next to each other so you can see what I mean. Over on the left, you've got labeled data. This is where we already know the right answers. The goal here is all about prediction. It's kind of like giving a student a textbook that already has an answer key in the back. But then, on the right, that's unlabeled data. There's no answer key, no cheat sheet. The goal here is pure discovery, just finding interesting patterns that you didn't even know were there. And these two approaches, prediction versus discovery, are really the heart of what we're talking about.
So let's take that first path, the one with the answer key. This is what we call supervised learning. The name says it all, right? We're supervising the machine, teaching it by showing it a bunch of examples where we already know the correct outcome. And our guide for this part of the journey is a really cool, super intuitive algorithm called K-nearest neighbors.
The core idea behind K-nearest neighbors, or KNN, is something you already know from real life. Birds of a feather flock together. Or, you are who you hang out with. It's built on this simple assumption that similar things tend to exist near each other. So, if you have a new, mysterious data point and you want to figure out what it is, you just look at its closest neighbors. You let the crowd it's in tell you what it's all about.
Okay, so this whole asking the neighbors thing sounds good, but how does it actually work in practice? Well, it breaks down into a really straightforward process. And what's cool is that this one simple idea can be used for two different kinds of prediction, something called classification and another called regression.
So imagine this. A new, unknown data point just shows up. The first thing the algorithm does is it measures the distance from this new guy to every single other point it's ever seen. From that, it finds its K closest friends. K could be 3, 5, whatever you choose. And this is where it gets interesting. If your goal is classification, like deciding is this email spam or not, the neighbors literally hold a vote. Whatever the majority says goes. But if you're doing regression, say trying to predict the price of a house, you don't vote. You just take the average price of all the closest neighbor houses. Simple as that.
And that's the key takeaway, right? The core method of finding the neighbors is exactly the same for both. The only thing that changes is what you do with their information. For classification, it's a majority vote. For regression, it's a simple average. It all just comes down to how you decide to combine what those neighbors are telling you.
All right, so that's the supervised world. Pretty neat. We've seen how you can make really good predictions when you have a nice labeled map to follow. But what happens when you don't? What if you're just dropped into a huge, messy cloud of data with no labels, no map, no answer key at all? How do you even begin to find any kind of meaningful structure in that?
Well, that exact question brings us to our second big path, unsupervised learning. And again, the name gives it away. There's no supervision. The machine is on its own. Its job is to dive into that raw, unlabeled data and just explore, to find natural groups and patterns all by itself. And the main tool it uses to do this is something called clustering.
You can think of clustering as automatic sorting. The algorithm just looks at everything and starts putting similar things into the same pile. These piles are our clusters. The one rule it follows is super simple. Make sure everything inside a pile is as similar as possible, and make sure the piles themselves are as different from each other as possible. This is exactly how a company might discover different types of customers just by looking at their buying habits, without ever telling the machine what to look for.
So, how do we do this? Well, one really intuitive approach is called hierarchical clustering. The best way to picture this is to think of building a family tree for all your data points, but from the bottom up. You start with every single point as its own little family of one. Then, you start merging them into bigger and bigger and bigger families based on who's most closely related.
The process is really methodical, almost like a recipe. Step 1. Every data point is its own cluster. Step 2. Find the two closest clusters and merge them into one. Step 3. Go back to Step 2. Find the next two closest clusters and merge them. You just keep doing that over and over, building up this hierarchy until eventually every single point is part of one giant supercluster.
Now here's a really interesting wrinkle. How do you define closest when you're talking about two whole groups of points? Well, it turns out your answer to that question completely changes the shape of the clusters you end up with. If you use what's called single linkage, you're just looking at the distance between the two closest points in each cluster.
That can lead to these long, stretched-out, chain-like groups. But if you use complete linkage, you measure the distance between the two farthest points. And that totally different rule forces the algorithm to create really tight, compact, ball-shaped clusters.
Okay, so that was the bottom-up family tree approach. Now let's check out a totally different philosophy for clustering, K-means. Instead of carefully building things up from individual points, K-means is way more direct. It basically starts by making a random guess about where the centers of the groups are, and then it just keeps improving that guess, over and over again.
It's really like a two-step dance that just repeats. Step 1, you randomly drop K starting points, we call these centroids, right into the middle of your data. Step 2 is the assignment step. Every single data point looks at all the centroids and gets assigned to the one it's closest to. Then comes step 3, the update step. Each centroid looks at all the points that were just assigned to it and moves to their average position. And that's it. You just repeat that assign and update dance until the centers just stop moving.
So this is that first critical assignment step in action. You can almost picture every single data point looking around at those first random centroids and asking, okay, which one of you am I closest to? Each point makes its decision, and boom, you have your first version of the groups, all clustered around those initial guesses.
And then comes the update step. The centers don't just stay where they were. They look at all the points that just got assigned to them and basically say, all right, everyone, I'm moving to the center of our new group. They recalculate their own position to be the exact average of all their members. You can see them literally drifting toward the true heart of the cluster.
And this cycle just keeps going. The points get a chance to reevaluate. Hey, that center moved, maybe a different one is closer now, and they might switch teams. Then the centers update their positions again. This back and forth happens a few times until everything settles down. You reach this stable point where no points want to switch clusters anymore, and the centers aren't moving. That's called convergence. And when that happens, you've found your groups.
So there you have it. We started with just a bunch of data and walked down two totally different roads. One used labels to predict things. The other used nothing but the data itself to discover hidden patterns. Let's pull back for a second and put them side by side to really nail down the differences.
This really lays it all out, doesn't it? On one side, you've got K nearest neighbors. That's supervised learning. It absolutely needs labeled data to work, and its goal is all about prediction. The key question it's trying to answer is, based on its neighbors, what is this new thing? Then you've got clustering. That's unsupervised. It thrives on unlabeled data. And its goal isn't prediction, it's discovery. The question it asks is, are there any natural groups hiding in here? So which one do you use? It totally depends on the data you have and the question you're trying to answer.
So, the next time you get one of those eerily accurate product recommendations, or you see a marketing report that talks about different customer segments, you'll have a pretty good idea of the simple, powerful logic that might be running under the hood. You can ask yourself, is the machine learning from its neighbors? Or is it off discovering brand new crowds all on its own?